Greetings and salutations. At the end of the last video, I mentioned that I would probably be writing some scripts for the teensy server. That was the last video's subject, me setting up a server on a tiny little netbook Asus EEE PC, and I kind of went through some of the trials and tribulations I had with that. Well, I have written some scripts, and this time around I wrote one with a menu in it, and we have not covered that on this channel in a very long time. Probably since I wrote XBT, and that's been 2 or 3 years ago now. So I figured it would be a good time to go ahead and post a video, talk a little bit about that, and talk about what I came up with for a script. And this is available to you if you want to get it. You can head to easylinux.com and then go to the Bash scripts page and scroll all the way to the bottom and look for the Easy Linux Bash Script Collection 2020. I just sort of threw this script in with all that other stuff, and you can download that from GitHub. And you can look at the other stuff in there as well. Just don't pay any attention to the README because it's really bad and it hasn't been updated in a very long time, and maybe someday I'll actually do that, but for now it's just sort of there. But yeah, there's a whole bunch of stuff in there that you can take a look at. So for those of you who are just joining us and have no idea what's going on, let me take a minute just to explain. A script is a small program that you can write for the Linux terminal, usually running in Bash, which is the shell that is what you get when you open a terminal. That's your command line interpreter, and it runs the commands that you put in it. Well, Bash is also a very powerful programming language. So you can write scripts that range from being just 1 or 2 lines to all the way to big, complicated programs. The idea is to keep them as simple as possible, keep them somewhere in between a great big program and a little bitty tiny script. And the reason why is that when they start getting really big and complicated, it's probably better to go on and write something in a more advanced or sophisticated programming language. But you can do a lot of really powerful things in Bash, and it's an easy language to learn. There is a book called The Linux Command Line by William Schatz. I highly recommend it to anybody who wants to learn more about how Linux works under the hood in the terminal. And I will put a link to that in the description. And as far as getting the script itself, you can just go to easylinux.com. There's a link in the description for that as well. And that book, by the way, is a free download as a PDF. So you don't even have to pay for it. I bought the printed version because I like that. I'm old school. I like books I can pick up. So that's what we're talking about here. If you're brand new to Linux and this might seem all a little bit over your head, I hope you hang around anyway, because you might learn something. You might get fascinated enough to want to learn more, and then you could go out and you could write your own scripts, and you could probably write much better scripts than I do. So let's go ahead and get into it. First, let me demonstrate the program. And yeah, I was going to do a video about whatever I wrote anyway, but then I decided while I was writing this that it would be fun to have a menu mode. I have not written menus for programs in a long time, probably since XBT, which was the big, huge, giant, gargantuan backup script that I posted, I don't know, it's been 2 or 3 years ago now, and I kind of changed my view on that. There are 2 schools of thought when it comes to writing scripts, and one of them is that, yeah, you should make them like big programs, you can have menus and all kinds of stuff, and then the other school of thought is, no, they ought to be really simple, they ought to run automatically, and you put the command in, run it straight through, and it just does what it does, and it doesn't stop. And that way you can automate things and you can tie them together with other stuff. So I'm caught in between. This time around I decided to put a menu mode on it. And I wrote it both ways. I wrote it so that it'll either run straight through and do what I want it to do, or I can stop and use the menu. So let's do the menu. Now the first thing that it does is it checks to see whether that little teensy computer is up. That's the server that I built and talked about in the last video. And once it confirms that that is online and up and running, the menu opens up and says, what would you like to do? And right now there's only 3 options because I just put this menu in for the hell of it. I could have made it so that you put an option at the end of the command. Like to get to the menu, you put in teensysync and then -- menu, which gives you the menu mode. Well, you can also access different modes of a script by putting different tags on it like that, different arguments. And for instance, like the up script, some of you are familiar with that. That's one that I have written, and it's on GitHub, and a lot of people have downloaded that and used it and adapted it to their own purposes. I wrote that script to basically show how functions and menus, or how functions worked. I didn't put a menu in it, and so that's what that's about. Every option is just adding something at the end. You can do up, and then you can do remove, and then you can do up and clean, and there's a few other things. And how you get to the help menu a lot of the times in my scripts is that way. It's the command, and then you put in -- help, and that takes you to the help screen. There's no help screen in this because I really don't think that I'm going to be putting this up on GitHub in its own repository to distribute that way. This is sort of halfway in between. I'm just sharing it with the audience here for guys who are interested, or girls, or whoever you are. You got to be so careful about what you say these days, you know. Anyway, if you're interested, you can get the script, but it's really not ready for prime time, and it's sort of something that works only on my network. You'll see when we look at the script. So I have this with 3 options, and the first one is to sync files and settings, which means that it syncs up data files, and then I also have it grabbing some settings from different directories and files on the host machine and sending it off to the server. And then number 2 here is sync files only, and that just grabs the files but leaves the settings alone in case nothing has changed or you're in a hurry. Or number 3 is just do the settings in case that you don't need to sync the files. Whatever, it's just different options. I was just goofing around, and of course 0 exits the program. So I'll show you what happens when you press 0. See, it just gets you right out. So if we run the command again, we're going to get the same deal, and we get the menu again. And this time around, I'm just going to, let's do 2. Let's just go ahead and run it all the way through. So I hit 1, and it just takes off and starts doing it. And there are actually some files to sync. So, yep, it's done the files, and now it's doing stuff from Thunderbird, and it is going to, it's syncing up those changes. Some changes from Google Chrome are being synced. These are all settings directories, and it says it's all synced up. Great. And then it says all done, and the program is done. So let's clear the screen with alternate and L, and let's run that one more time. And I want to show you what happens if you put in a wrong thing. So the only valid responses in the menu is 1, 2, and 3, or 0. That's it. You put anything else in, I'm going to hit number 5 right here, okay? And it says, not a valid choice. Try it again, and it just reloads on the screen. It does it again. Well, let me try the letter H. No, that's an invalid choice. Well, all right, well, what about enter? That's still an invalid choice. So the only way to get out of this once you get into the menu is to press 0. That's it. Now you see why you don't want to use menus on things that you intend to automate, because it hangs up and it waits for user input. It'll do that every time. Of course, you don't necessarily have to do that. What you can do in a situation like that is to use Control-C, and it should do exactly the same thing. Yep, it just gets out. So Control-C is kind of like the universal cancel function, or close, or whatever that is for programs that are running in the terminal. Anything you want to stop, you can hit Control-C and it'll stop running. So you get the idea of how it works. Now if I fire this off without any argument, I just typed in the name of the program, now it goes into a fully automated mode, and it's now doing its thing without asking any questions. It's not prompting for anything, and it's saying it did it, and now it goes on to the settings, and now everything is all synced up. Of course, we're not seeing anything as far as files getting transferred because there aren't any to transfer. We just did it. So let's look into the guts and show you how it works. And I'm going to go through this line by line, and I'm going to explain what each part of it does. Like I said, if you're not somebody who's familiar with scripting, some of this might go a little bit over your head, but I do urge you to stick around. Somewhere on the channel here, I have an introduction to Bash scripting series. It's like 4 videos, and honestly, I never finished it. There's like one more video to do, and I never got around to it. And I recommend you guys take a look at that if you want to. A lot of folks lately have been looking at those videos. The #1 video on my channel is Beginner's Guide to the Bash Terminal. And I just noticed that like #3 right now is the Beginner's Guide to Bash Scripting. So that's awesome. People are really interested in this sort of thing right now. Okay, so let's jump over here to the editor. And since we're running Linux Mint, I'm using their lovely Xed, which is a fork of Pluma, and I like it an awful lot. It's one of the reasons that I have stuck with Linux Mint after doing the revisited video a while back, is I really was enjoying using Pluma. So, what happens in this script? First of all, up top, we'll just kind of go through this for those who don't know what a script is. This is your shebang. And it's the old school hashtag, and then the exclamation point, and then it's what command line interpreter you intend to use for this particular script, and we're using bash. Now in Ubuntu, the bin directory no longer exists. They have moved all that was in bin, right there, to user/bin, usr/bin. And I had originally, on some of my scripts, changed it over to reflect that change so it wouldn't go through the link that is provided, because that's what Ubuntu did. Debian did this as well. That's why Ubuntu followed through on it. And so they had moved that bin folder to user/bin and combined those two directories. Well, guess what? Linux Mint, I just found out that one of the things that separates them from Ubuntu is they actually have a separate bin directory. So this seems to be the best way to go. And before anybody jumps up in the comments and says, well, you could do the environment command. So it's instead of this, you do, let's see, it's shebang, and then it's user/inv space bash. And that is another way to do a shebang. That's a newer way. I don't particularly like that one. I like the old school way to do it. Comments here saying what it does. And yeah, I do say it's under the GNU General Public License here, but I really don't care. I don't want your patches. If you want to take this and play with it and adapt it to your own use, go right ahead. I don't mind. Okay, the next thing that happens in the script is that we load functions. And functions are essentially groups of commands, scripts within a script that we can put into memory and the computer hangs on to, and then we can call them later. So we just create these little programs, these little sets of commands, and give them a name, and they get loaded up into memory, and then later on we can call them. So the first thing that you want to do in a script is to declare your variables, which we don't have any of in this script, and that would be any value that you want set in the environment. We've talked about that in the past. I'm not going to get too deep into that. We just don't have any variables in this particular script. And then the next thing you'd want to do is declare your functions. And so let's go through the functions. So the first function that we have here is the file sync function, which is the basic one. This is what I started out with, and it says syncing files to teensy file server, and then it runs this rsync command right here, which is actually very straightforward, and it just sends those files over the network using SSH. Rsync assumes that you have SSH up and running, and that's how it will reach out to another server on the network if you use the right syntax. So essentially what it's doing is it's grabbing all these files, it's doing that, we've got the archive set, it's verbal, which means that it's telling us what it's doing, and the big H there is so that it will take links over without following them. And I don't think that's really necessary, sending it across the network, come to think of it, but it doesn't hurt that it's there at all. And then we have delete, which means that if there is anything that has changed in the source that has been deleted, to delete it on the destination. In other words, we're creating a perfect mirror, show the progress. That gives us some feedback on how long this is going to take. And then we're grabbing these directories: audio, bin, chart hits archive, desktop, documents, downloads, music, pictures, and videos. Pretty much everything on this host computer is going over except for a directory I have in there called work, because that's just junk stuff and I don't need to sync that. and then it is going to this computer on the network 192.168.0.12, and you put a colon there and then tell it the directory, and in this case it's going into my home directory, which is /home/Joe. It's pretty simple stuff. If you are sending into an account that's not one that is yours, then you can do the same thing. You would just put that account name @ in front of that. So if I was sending it to Cindy's account, I would put in something like Cindy @ right? Well, not Vendy, but you get the idea. Let's make it look right. There you go. That's how you would send to another account. Now, probably at that point, you're going to be stopped and asked for a password if you're going into somebody else's account. But because I'm doing this into mine, and I already have rsync set up to automatically log me in with the keys, or SSH rather, to log me in automatically, we shouldn't have any issue. It goes straight in. So that command runs and it does its thing. And when it gets done, what I have the system doing is checking on the status of rsync, making sure there weren't any errors. So it looks at the errors from the error output from the rsync command when it closes. And usually the way that works, when a program or command runs, it will leave in this variable right here, this $? That is a variable, a 0 if everything went the way it should. If it's any other number besides 0, then that means that there was an error. And why would it be different numbers? Because different programmers assign different numbers to different kinds of error. They can query this particular variable here in the shell, and they can go, oh, well, that's 148. I know what part of the program didn't work. But for general purposes, you can just not even worry about that kind of garbage. You're not working on the program like that. You just care if it's 0 or not. So if it's 0, then it echoes all files are synced, and then that's it. It's done. If it's not 0, then that means there's an error, and it puts up this error message right here. Okay. And I always like to, when I put up error messages, to always have some sort of help associated with it. Like, really, if you got an error, that would just mean that a file changed in the time that it took that it went over, most likely. And if you run it twice, the error goes away, because then it's able to fix the discrepancy. So that's why I say try running sync again. And of course, this stuff right here. For those of you who are new to scripting, when you do error messages, you use this little guy right here. Probably over here is easier to see. And what that does is it sends it not only into the standard output channel that you see on the screen, but it also sends it into the error channel, which is two different things. And the reason why there are two different things is you can send the output channel to the input of a file, for instance, or another program, and you really don't want errors going there. And sometimes if you're sending output somewhere else, errors need to show on the screen. So that way you can see the errors. And it actually puts that in both channels, is what that little guide right there does. And so we have the next function. That's the first function. Second function would be setting sync. And this is exactly the same command. I just copied and pasted, except we are now grabbing a bunch of different files and settings here and throwing them into a directory on the Teensy server called teensysync settings backup. So it grabs all of these different settings directories and just throws them in there. And then it does the same thing. It checks on the status. And this time around, it's kind of interesting because, let me see, did I do that? No, I did it right. I did it the same way both times. Don't worry, there's what I'm talking about you'll see later. So it says if the output, the exit status of rsync equals 0, then settings all synced, and move on. Same errors if it doesn't. Okay. Next function is just all done. And all this is just a fancy way to exit a program, is to actually have a function that does this. And the reason why I put this in here was to simplify the menu, which you will see coming up shortly. And this just makes it easier to figure out how the program is going to exit, and cleans it up later on. Exit is a very powerful command. Exit means, when you type that in there, that this script stops. The program quits. Doesn't matter how much there is left to do. Exit means quit, go back to the prompt. You're done. And so this basically ends the program, and then it exits, and because there's nothing after the exit, it gives a exit status of 0, meaning that the program ran the way it should. So now we come down to the menu, and this is the part that I wanted to show you guys because I haven't shown this in a very long time. This is called a case menu, and they are stupid easy to do. They are just unbelievably cool. And if you want to write a script with lots of different options and you want to have different menus in it, this is how you do it. So the first thing that we're going to do is create what's known as a here document. And a here document is just a block of text that you're going to show on the screen. That's all it is. And it starts out, we're using the cat command to do this. And it's just going to display the text on the screen because that's what cat does. And then you're telling cat here that the information is going to come from, basically from here to here. All right? We don't want to get that EOF. This is the here document itself. And you see that we start out with this token, EOF underscore EOF to underscore EOF. This is the end of file token. That's what this does, is it tells cat when the file, which is just stuff right here, ends. So cat will grab everything from here to there, and you can actually use anything you want for an EOF token. This is just the standard way to do it. But I guess if you were doing a here document that was talking about how here documents worked, you might want to use something different so it doesn't grab EOF. But it doesn't really matter. You could come up with your own. You can use other programs with here document besides cat. You can use things like less, which is a file viewer. In other words, if you have a here document that's really long and it'll scroll off the screen, then you can use less, and then you could use the spacebar at that point to scroll through different pages. You could use more as well, which is a simpler pager. I know, yeah, less is more. It really is. So that's going to display that on the screen, and then the next thing that you're going to have is this read command right here. Now the read command grabs input from the user, and what it is going to do is read whatever is asked of the user. And let's see. I'm not really sure if I remember what the N does. I know what this command does, but I'm not too sure about the those particular arguments at the end of read. But what this does, I'll tell you why I'm not sure, is because I cut and pasted this from somewhere else. In other words, I looked it up at one point to figure out how to do it, and then I kept it and I cut and pasted in, and that's perfectly all right. Keep everything you write, and that way when you need to assemble something later, you can. But what this does is it stops and it asks the user a question. You essentially get a blinking cursor, and whatever they type in, it goes into this variable right here, which is choice. See that? So we're going to create a variable called choice. A variable is nothing more than a little string of information that you would like the shell to hang on to. That's it. So let's say that they put in number 1, and it goes into choice, and it is waiting for that variable to show up. In other words, that's why it waits until you actually type. And when it does, because we're doing a case here, and a case is that the command line interpreter is actually watching this variable to see if it changes right there. And if it does, then we say, all right, you do whatever is on this list next. So it's case, our variable that we create, and then in. It's flip-flopping. In other words, you can flip-flop the logic this way. In case the variable is 1. It just does it in reverse. It's slightly out of order. So you type in 1, and then the first thing it does is run the function file sync. And then it echoes this line to the screen, moving on to settings sync, and then it runs the settings sync, and that's it. And so that option ends, and with all done. And it shows that everything's done. Now in all done, it exits, which is perfectly all right, because that's okay that it runs that way. Now, if we just want to sync files, we choose number 2, and now we get file sync, and then we have the double colons at the end there, indicating to the system that that's the line and it's done. You can have as many different things run. These are just different commands that are on one line here in the menu. Okay, and it does that, and then it dumps. And once it's done, it moves on, and then the next command that it sees is exit, and it exits the program. It's that simple. But I didn't want to put all done there because it's not really all done. It only did some of it, right? So if it just does file sync or settings sync, then it's not really all done. So 0, that would be goodbye. So what we're having the machine do is to echo exiting, goodbye, and then it just dumps out, because there we have the 2 colons, and that's it. In this case, a single colon between commands indicates to the command line interpreter that that's a line. That's what that does. It separates these things. It says, okay, move on to the next thing, which is just like moving on to the next line. So if you press anything besides 1, 2, or 3, that's when it goes to the asterisk here, or the glob. And that glob is just like the wildcard that you would use to do something like tell your system to remove every file in a directory that was glob.jpg. Okay? It just means everything. So anything besides these 3 characters, it won't activate any of these choices. So it's top down. It has to be in order. And this has to be the last thing that you put. And you really need to put that in there just so that the system doesn't get confused and it lets people know what's going on. So what it does is it says, not a valid choice, please try again. And then the computer sleeps for 2 seconds, so it leaves that up on the screen. Then it clears the screen, and it reruns this menu. It's this function. It grabs this function and it restarts it to reset the menu. And of course, in the process here, we echo the name of the program. So if we didn't do that, then what you'd see on the screen is just it said main menu, and somebody might get confused. So that's why I took this extra step to have it do that right there. All right, one thing I need to point out in here, because some people have said this before, this is a way of doing a new line, and yes, I know there's a lot of other ways to do new lines right there, but that's how I learned early on, and like I said, I copied this from another script, and usually when I need to do that, that's the syntax that I use, but there's actually several different things that you can do that, and a new line is basically like hitting enter. So that's a case menu. Plain and simple. That's how they work. They're super easy to do. So you write your variables up top, and we don't have any variables in this program, of course, but we have our functions. We have all of our functions, and we load those into memory, and then if somebody chooses the menu, we go to that, and it loads the menu there. Here's how the menu works. It runs the functions in the order to go along with the choices in the menu, and then it exits. So what about if you do it automatically? Well, now we get down to the part of the script which is execution. And this is the automated portion. This is the part that actually runs the code. So when you type the command, it loads the whole script into memory, and then it starts running the first thing that it sees. That is a runnable command. And in this case, the first thing that it sees is to check for that server and make sure it's online. So it pings the server, and it does it 3 times. And if it gets a response, then what it will do is check the exit code of ping, and if that's 0, that means that that server is online. In this case, we take all the output from ping. We don't want it to show up on the screen anywhere, and we put it into dev null right there, which means that it'll all go into dev null. And this right here means that not only will the output channel do that, but the error channel will do that as well. So standard in, standard out, standard error. Those are your 3 channels for data that happen in the terminal, or actually any program that you exit in a Linux system. That's it. They all go down those different channels. And so this way it will take the errors, everything goes back into dev null. What is dev null? That's the bit bucket or the trash can. That's where if you generate data that you don't want to do anything with, you just send it there and it disappears. And that is a virtual device on the system. It acts like a file or a hard drive. You can write to dev null, and when you do, it just disappears. It goes away. So if it's not online, obviously it's going to tell you it's not online. And it is technically an error, but not really, so I didn't label it as an error message. But the exit status of the script in that case is going to be 1. That shows that there was an error. And there you go. All right, so this is the part that checks for the menu argument. We're using a simple if statement. If is a test. We are looking for some condition in the system, and if that condition is met, then we will do something. So in this case, I wanted to show this too. In this if statement right here, you'll notice that it is an exclamation point in equals. That means that it is not equal to. And I did that differently here because you'll notice that if doesn't kick in, this code does not even do anything unless that condition is met. If not, it just goes on. There's no else. So I'm not saying if do this, if then else. It's just if then here. And there's your then command right there. That's why that's that way. So you can test either way. You can test for it to be there or not to be there. And then you can structure your logic from that point on accordingly. All right. Now, to get it into menu mode, it's just real simple. If the user types in for the first argument after the command, and that's what this variable means right here, right there. All right. If that equals -- menu, then guess what? The program just will go into this particular mode right here, and it will grab that function, and that's what will run, and it won't let anything below that run. Once it goes into that function, since we're doing it in menu mode, we're not going to be executing anything else. If you try and fire off the program, what this does right here is basically it's saying if this function is not let's see, what is that? I'm trying to remember the logic behind that right there. And I'm kind of getting messed up because I haven't really paid attention to this in a long time. It's funny, you walk through these things and you forget. Anyway, what this does, I'm not quite sure what the in option is. It may be that if it is not, or if it's anything different from this, yeah, it just means if there's anything in there and it's not this, the in, right there, then it's going to throw this error. So let's make that happen so you can see how that works, because that's really easy to demonstrate. So let me open up another thing here and make it a little bit bigger to make it easier to see. So let's type in teensysync menu, and menu, right? And it throws it into menu mode. We'll go ahead and exit that. So that worked the way it's supposed to. Now, if I typed in anything else, let's just type in ME. See, it's not a valid choice. And the way that works is, if it ain't menu, it's going to go on to this command. If it's anything else, that's basically what the in is. Just read whatever they put in. And if it's anything else, then throw this error. So that's how that works. And then down here at the bottom of the script is the part that actually does the execution once we have made it through all of these different tests here. If we've gotten through all of the if statements and everything just kept on going, then down here we get down to the bottom and we run file sync, and then we echo that we're moving on to settings sync because that obviously worked properly. It didn't exit. And then if that worked properly, then we go to all done, and that's the end of the program. That's how it works. That's a very simple script with a case menu in it. And like I said, if you want to actually look at this script and look at it, then have at it, have fun with it. I did proofread the script rather carefully, but I know probably I got some spelling somewhere wrong, and somebody's going to point it out. Just to let you know that if you're real worried about it, you can download it and change it on your own script. I've got it to where it works for me, and I'm going to use this as is right now in case I come up with something new to do with it. I try not to let them get too complicated because you can go crazy with these things. And if you have a really large script that takes a very long time because it has a lot of tests and a lot of functions and a lot of options in it, then it can slow things down. You need to keep them as simple as possible. Let me give you an example of a script like that. This is written in Bash, and I keep it around to steal stuff out of because it's such a really cool script. And I'll show it to you in just a bit here. The code, actually, I'll show you. But let's just run it right now. We got documents, and then we want scripts. And the name of the thing is screen fetch, right? Isn't it screen fetch? Yeah, but you'd get it if you put the C in there. Yeah, screen fetch. So there's a delay. Watch this when it runs. There's a bit of a delay. Ooh. There's something in there it didn't like. It's got a bad line in there. Warning. Okay, that's the first time I've ever seen that. This is not a script that I wrote. Wonder why it did that. Anyway, you see that it takes it a second to run and actually display on the screen? Let me show you why. So if we open this up in a text editor, oh, scripts, dummy, scripts. Okay, screen fetch. Yes, I can type, but not while I'm doing videos, because I'm too busy thinking about other things and I hit the wrong keys. Okay, so this is this script, and very well written script, by the way, and they're using this for compatibility. I don't particularly like that, but like I said, I didn't write this. This was written by Brett Bonnenkemper. Bonnenkemper? Yeah, Bonnenkemper. I'm sorry if I messed up your name. So let's just take a scroll through this thing. It's a very large script. This goes on. Let's just page down. Just keep paging and paging and paging and paging and paging and paging and paging. There are many lines in this script. I think there's 4,000 or 5,000 lines because he had to have all these different things to load up into memory for it to choose from. These are all the different symbols for the different distributions of Linux. So you get the idea. All right. Guess that's it. Just an introduction to that. I told you I would be writing some scripts, and I like to talk about these when I do them because people are very interested these days. You can get it at the Bash Scripts collection. That's on the Bash Scripts page at easylinux.com. And I will put the link to get the book as well in the description. Thanks for watching. Thanks for your kind attention. Your comments and suggestions are always welcome. Check out easylinux.com for more about the Easy Linux project. And also, while you're there, take a look at Easy Talk, which is our forum, and become a member if you want to become a part of the community. It's something that we run ourselves. It is not part of any larger organization like Discord or Facebook or any of those sorts of things. It's our homegrown forum. Give it a look. We'll do it again soon.